Okay, D and E, we're just going to do a lot of the same functions repeat. Coincident, 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 and then either of those faces, possibly edges. We'll take a look at one of the edge combinations. I'm saving points for last, so maybe on the next one we'll do a point example. So if I do File New this time, Assembly, we're going to bring in the block. I'm going to go ahead and accept. And we've been doing the Control Select and Drag. If that is, it takes a couple of tries and combinations to kind of get the when to let go of the mouse button, when to let go of the control button, and bring in another block. With the insert components, it does pretty much the same thing. Right, so select, control select, coincident, and then select. And I'm pretty much just picking what I can see. There's going to be times where I'm going to make, I'm going to say, a more discrete selection, and there is the mate alignment. And I can move that out a little bit. And we'll go face to face. Now I was thinking about that intersecting edge, but when I saw that going coincident and that going coincident, um, it's if I use the edge, it would allow it to rotate. So I'd actually need two edges there anyway, and they're a little harder to select. So let's look at the suppression states of those two. And in the mates, and this is going to lead into, we saw the selection for configurations. This is going to kind of lead into configurations. So I'm going to suppress those, which means just like in the part, those features or those mates are not going to participate. So if I wanted to go edge to edge, I would be selecting the interior and the exterior and go coincident. And then what I was looking at was the rotation. And while that's really cool, it's not what I want. And then edge to edge would be pulling it into position. So I still have two coincidences. It's just the features or the selection varies with that geometry. All right, and then this one's going to be D. Oh, and let's make sure to drag that in. We're not ready. So E, we're going to look at with points. Now I'm not going, well, no, I will rotate. I was going to say we need to do a little more with the rotation. So the blocks are coming in from the part in this. We're going to rotate this up with the mates so that we have a little closer to that description. Is it necessary? Nah, not really. So new assembly. Whatever we're doing with this is we're trying to make the picture, the visualization in our heads match what's on the screen. So we'll go ahead and place it. Now the first part coming in fixed is generally fine. I would rather have it do that. The design intent says that if I have picked my base piece and when I created it, put it in the right orientation, I shouldn't have to do this, and it can come in, it can just be fixed, and it's not any big deal. So let's go through the first ones, top plane to the selection, coincident. We'll rotate over to the right plane, coincident, and rotate over and front plane, coincident. And it doesn't really matter the order, it's more that I could see those in that space or in that orientation. I'm going to hold down the control button again. You can go to insert components, I believe on the right click. We haven't really looked at what we have available on the right click. So zoom to fit, zoomed area, zoom in and out. We haven't done much zoom in and out, so let's just go through these real quick. Zoom to fit, zoom to area, and then zoom in and out is going to be a left click, hold down, and kind of operate the zoom manually. And then I'll escape. Pan. Right, so moving the view, not the part. In this case, there's one part, and it looks like I'm moving the part. If the origin was on, we would see that it's stationary. If there's other parts, we would see that they're all moving together. If I was moving the part, I think I said that wrong. If I was moving the part, or the part was capable of moving, the origin would stay stationary and move around it. If I am moving the view, the origin, other parts, they all move together. And then the roll view is in that view, that planar view, it's rolling in the direction of that view, not necessarily rotating the part freeform. What else do we have? Nope, don't really need those. I think we're good there. Haven't done too much with the selection. If you prefer the lasso is kind of a more circular. Shouldn't need those just yet. Selection sets, selection filters. All right, so nothing really of use right now on the right mouse button. And we'll just kind of, okay, so we do have a mate there and view mates. Right, so the list of mates for that part, and can kind of go through those pretty quick without expanding it out. All right, so let's just do the control. Left click, hold down and drag, let go of the mouse button, let go of the control button. All right, last on my list is points to any of the others. Points to plane, points to face, point to edges, point to point. And so point is the smallest of the targets. And if I go point to point, kind of the problem with the point is it is a full orbit. All right, so 1 point is not going to get it. 2 points pretty much act like the edge, and now it's able to rotate. And 3 points is pretty much what we're doing with the others. They're just easier to select, in my opinion. So now we're at the stage where we're looking at the 6 degrees of freedom. So I'm going to suppress at least one of these so we can have that rotation. And probably not, let's see, probably not my best example. I'll wait on that for a second. So I'm going to unsuppress that, bring it back in. We'll do the save and make that go to E. All right, so 6 degrees of freedom we'll do on part F. And so we have the 2 blocks. Still, it's rotated up. And this is also where we can maybe take advantage of rotating this around. So the rotation, I have the reference triad. So if I've used the rotate view and got this out of position, I can reference real quick that I need to rotate this about X. Right, so that rotates it into position, but if it had gone the other way, I could just keep rotating it until it gets there. Once it's in that position, then I can hit the OK, and it will jump to origin and apply the F for fixed. That's all I have to do at that point. I don't have to float it and bring it in or do anything. We're going to stay with that fixed origin to origin, and then the orientation of the planes is all good there. All right, so bringing in the next component, then let's do the edge first, and we'll go coincident to there, so they have a location. So 6 degrees of freedom. This is now constrained. It does not move back and forth, left to right, but it is able to move up and down and to rotate. So the 6 degrees of freedom we need to constrain is, let's use x, and rotation about x is our 2 degrees of freedom. Y, moving up and down in y and rotating about y, are 2 degrees of freedom. And then z is coming towards us, and that would be the same, moving back and forth and rotating. So x, y, and z based on our triad. All right, so there are going to be times where we want to simulate motion and see that motion. So being able to address that that geometry, I will divide it into static and dynamic when we get to that point, and kind of treat them as separate, same but separate entities. All right, so my fingers were ahead of my mouth again. We're going to select the face, control select the face, go to coincident. And if I'm in the mate, then the blue box is highlighted, face to face, not the selection that I wanted, flip mate alignment, go back over to the property manager, find the alignment, but the in context is definitely going to be fastest. And we'll accept and save this as F.